Okay, boys, today we're looking at circles. Now, a circle, it's not a function. So, if we draw a circle, vertical line test, straight down, we can see that it crosses twice. So, it's not a function. It is a relation, though, and we do need to understand the nature of this relation. And we'll start by looking at the circle with center 0, 0. Okay, so to find the formula for that, we can just use a general point on the circle and use Pythagoras' theorem. So we can see if we call that point xy, the relationship between the three sides, x squared plus y squared equals r squared, and that gives us the set of coordinates as x and y change for the circle as it goes around. And so the equation of the circle, the center 0, 0 and radius r is, that doesn't look great there, so we'll just put it here, x squared plus y squared equals r squared. So where r is the radius and x and y are our two variables. Okay, so let's look at an example. Let's consider this function, x squared plus y squared equals 4. So we know from the form of the equation, this thing here is r squared. And so that means if r squared equals 4, then r is going to be equal to 2. So to sketch this, we're literally looking at a circle that goes through 0, 0, and a circle with a radius of 2. So it's going to go up to 2 there, minus 2, minus 2, and it'll be a nice little circle that will loop around. Nearly looks like a circle. All right, so that's the basic. So why is this guy not a function? Well, it fails the vertical line test. Alright, so domain and range of this function. Graphically is quite helpful to see the domain and range. We can see that the domain goes between minus 2 and 2, and the range also between minus 2 and 2. So the domain is going to be, it's going to include minus 2 up to 2, and the range is going to be the same. So fairly limited scope for the x and y values. Alright, so what if we don't have a circle with a center of 0, 0? So look at this circle with center AB, so not at the origin. We're also going to look at how it works sort of graphically. I'll sort of derive that equation. If we take a general point xy and our circle has a center of AB and the radius is r, if you look at this diagram down here, you can see that, so this one here, you can see that the smaller sides of this triangle are x minus a and y minus b. And r is of course the radius. And so combining all that, like we did before using Pythagoras, squaring each of the shorter sides, adding them together, and that equal to the hypotenuse squared, we get this formula here. And that's the equation of a circle with center AB and radius r. Alright, let's look at a couple of different examples. Okay, so what do we know about this equation here? Well, straight away we can see, we can look at its center and also its radius. Well, the radius we've already seen, so the radius squared is equal to 4, and so the radius is equal to 2. Now what about the center? Now the center, we've got a -1 there, which means the x value for the center is going to be 1. And this is now a plus here, so that means it's a minus value for the y and -2. So we're going to have a center of 1 minus 2, which is right here. It's going to have a radius of 2, so that means it's going to go up as wide as that point, up to there. Okay, and so that will be our circle. So they're fairly easy once you get the hang of this system here to be able to sketch pretty quickly. So there's our center. I know this point here, for example, would be the point 3 and -2. Okay, there's our circle. Now, domain and range for this guy. Well, our domain, you can see from our graph, it goes as far as -1 and including that, and it goes up until 3. Including 3. Range, we've got down to -4 and up to 0. Alright, let's now find some equations. So find the equation of a circle with radius 3, center -2, 1. Okay? And we want it in expanded form. So let's put it in the standard form first. So, because it's a minus value for the x, that'll make that +2 squared, and then we've got plus y -1 squared equals radius of 3, that will make that 9. Okay, so simplifying that, we've got x squared plus 4x plus 4 plus y squared minus 2y plus 1 equals 9. And so we can sort of gather that up if you'd like. X squared plus y squared plus 4x minus 2y, and we've got plus 5, and we're going to bring -9 across. -4 equals 0. Okay, so that would be expanding that out. All right, question 4. Find the center and radius of the circle with this equation. All right. Okay, question 4, they've asked us to find the center and radius of this circle. Now, what's interesting about this circle is it's not in a very helpful form, and so we need to get it into the form of that we wanted, the sort of general form, x minus a all squared plus y minus b all squared equals r squared. So to do that, we're going to complete the square on both the on this part and this part of the equation to get it. So yeah, you'll be reminded of completing the square. The whole idea is you find the square that will give you those two terms, and then the last little bit you add on to the other side is whatever that value squared is. So well, let's just see that play out. So first I'm going to move the 6 over to the other side. So I'm going to get x squared plus 2x plus y squared minus 6y equals 6. Now I'm going to complete the square in the first bit. So that is the same thing as x plus 1 all squared. And the extra value that I'll add to the other side to balance it off will be a 1. So over on this side it's going to be 6 plus another 1. And now over here I've got halving that, because we always halve that b term, and we're going to get y minus 3 all squared. And of course that last term, if I expand that, would be another 9, so plus 9. Alrighty, and so now I've got it looking really nice, and so we've just got to simplify the right hand side. So we're going to have x plus 1 squared plus y minus 3 all squared equals 16. So now it's in the form that I want. I can conclude by saying, well, the radius, that's going to be equal to, well, the r squared is 16, and so the radius is 4, and the center is going to be the point minus 1, 3. Fantastic. Hopefully you got the hang of working with circles. Good luck with your exercises.